In this example, we would like to find the location of the pole. First of all, we need to find out how many poles are in this circuit. So we have pole number 1 and pole number 2. And you need to consider the input as an AC ground in that case. And the pole number 1 can simply, you have RS, which is connected in parallel to 1 over GM1. So that's the reason we have the impedance RS in parallel to 1 over GM, and the capacitance connected to this node is C input. So 1 over RC will be its pole location. And another pole can be obtained through this path. In this node, we have the impedance of the resistor, which is RD. So we have 1 over RD times CL, which is the location of the second pole. This is another example which needs to consider Miller capacitor. If you have a Miller capacitor like that one, you have converted this one into two different capacitors, input capacitor and output capacitor. In this case, C input is given by 1 minus my gain, which is minus GM1 times RD times CF. And the output capacitance, C output, will be 1 minus 1 over GM RD times CF. So it will be plus positive value. So based on the obtained C input and C output, we can find out the location of the pole in here and there. So input pole location is simply, if you put this one to ground, it is RS, 1 over RS times this value, which is given by that one. And also the output pole location is 1 over output resistance RD plus is output capacitance by Miller effect is given by that one, as we obtained in here. And this is an example to finding out input and output impedance and its pole location. Let's talk about this node and that node. This is an input input is connected to the gates, and of course we have capacitor and resistor array. That's the same as high pass filter. And also we have a impedance, which is 1 over GM, and capacitor connected to the ground, so it can be considered as a low pass filter. So by having that one, the input pole frequency is simply 1 over RC, and R in this case is RI, and C in this case is CI. So put that value, then you can simply get the pole location. And second pole location is the same. That's still 1 over RC, and here R is 1 over GM and C is the same as CL. So if you put that value GM into this equation and CL into that one, then you can come up with the final result. And of course, the output pole frequency should be lower than 20 kilohertz, right? So based on this one, you can obtain CL. And for the input high pass filter, you have a pole location. So by putting 20 hertz, you can come up with a CI. So of course, by having CI, you can find the frequency, or by having the frequency, you can finding out the capacitance value. This is an example with parasitics. So in this case, we have two BJTs connected in cascode, and the output is connected to RC. And in general, a BJT has three capacitors, parasitic capacitors, which is C mu and C pi and to ground C CS. The same for Q1. So we have 1, 2, 1, 2, 3 parasitics, and also 1, 2, 3 parasitics. However, you have to be very careful that VB is AC ground, and also VCC is AC ground. So if you are looking at this condition, you can finding out this C pi 2 from this node to AC ground, this CS1, that one, and that one are connected to in parallel. And also C mu 2, because this is connected to ground, C mu 2 and CCS2 are connected in parallel because VB is connected to AC ground. Since a MOSFET transistor has 4 parasitics, which is the same as, in this case for M1, C, GS, and C, SB, and C, DB, and between the gate and the drain we have CGD. So we have 4 parasitics for M1 and also 4 parasitics for M4. So we can come up with this result. And based on this complicated capacitance array, we need to finding out which one can be cancelled out. So as long as 2 nodes of a capacitor are connected to the same node, which means that this one and that one are connected to the same, then actually CSB2 can be cancelled out. You don't need to use that one, that's redundant. And also we have diode connection, so CGD can be cancelled out. And what else? And also we can cancel out CSB1 because both nodes are connected to the ground. Yes, that's it, I think. Okay, let's move on. And also, if you're looking at CDB1, that is connected to ground from this node, and also CDB2 is connected from the output to AC ground. So that one and that one. And also CGS, if you're looking at this node, because they are the same node, this node is connected to the outputs, and CGS2 is connected in between output node to AC ground. So you can just summarize that by using just one capacitor. Instead of putting three capacitors, you can just put one value for this capacitor representing three different capacitance. Thanks.